I've always said that performance work is, in fact, investigative work. I don't want to make it seem like it's macabre, but I've often compared it to like a crime scene. Because you're looking around like, okay, you popped open, web page tests, and you just look at your waterfall. You're like, okay, what's that over there? Okay, that might be a shell casing. Okay, and then you see some blood spatter on the wall, and you're trying to figure out how the blood got there. Then you get a little closer. You're like, okay. Then when they have those little things in the hole, and they want to figure out the trajectory of the bullet. That is performance, sort of auditing to an extent. It can feel like boring work, but it is absolutely rewarding, especially when you solve the crime. Here to talk about being a performance detective is, give it up for Katie.
Excited to be here, but I'm also very rusty at this, as you can see. So anyways, okay, hi. Yeah, I'm Katie Sylor-Miller. Oh, did that work? Let's expand. There we go. Okay. Technical difficulties over. So I don't know how many of you were here in 2018, but I gave a talk called Raiders of the Fast Start that had an Indiana Jones theme. So for this talk, I knew that I needed a theme. And I was like mentally kind of going through, okay, there's like Sherlock Holmes, there's Hercule Poirot, but I need something that's going to be super relevant, like cross-culturally for this audience. And so it hit me. What about Detective Pikachu, right? And this is clearly the best theme because we've all been talking about, we have a lot of performance metrics, and we got to catch them all. So what does it actually mean to be a perf detective? Well, let's say that you're pretty high up in that ziggurat, and you've added logging and monitoring of all of your performance metrics. You've got your perf budget set. You're cruising right along until all of a sudden, womp womp, some metric gets worse, and now you have to figure out what the heck just happened. Why did that get worse? And this can be really challenging, I think, especially for folks who are newer to the performance space, because there are just so many darn metrics that you have to keep track of in your brain. And sometimes it feels like those veterans are like Sherlock Holmes, and they walk into the room and they're like, yes, the culprit is a one-legged sailor from Belgium who likes to eat cheese and sleep on the left-hand side of the bed. It looks like magic, right? But I swear there's a formula underneath there. And I'm going to try to kind of help demystify this mental process of figuring out the culprit when your core web vitals in particular get worse. Thank you. But first, I want to share a couple of what I think are like really hard truths about performance in general, and particularly when you're trying to be a performance detective. And the first hard truth is that every single byte of HTML, CSS, JavaScript, video, images, whatever you add to your site, if you're not careful, it's going to make things slower. Web performance is this constant fight against this headwind of, as you're doing that feature development that Dora, again, that we didn't plan this, I swear, was talking about, you're going to have to keep fighting against that. So web perf can kind of sometimes feel like it's death by 1,000 cuts. And the second hard truth, and I swear also I did not coordinate this with Nolan, but it depends, Sometimes you're going to make a metric worse, and that's okay. Sometimes you're going to make that same exact metric worse, and it's not okay. Like, for example, if you add lazy loading of all of your images that are below the fold, you're probably going to make your page load time worse. But that's okay, because maybe LCP is going to get better. Other times, you might make page load worse by adding a megabyte of JavaScript. And that is definitely not okay. So that's really hard, right? And I think the third hard truth is there's really no one right way to measure site performance. There's a bajillion different ways that you can do it. And it would really be impossible for me to cover all of those different ways that you can monitor perf. So I'm going to start where we generally start at Etsy, which is near the top of the ziggurat. Yes. We have all of our RUM data collection gets piped into our experiment A/B platform pipeline, and we report on web performance changes for literally every single one of the hundreds and hundreds and hundreds of experiments that we run every year. So, if you do lots of A/B testing, you might want to do this as well. If you don't, it might be worth it just because, that trying to figure out what changed is a lot easier looking backwards if you have a before and after state that you can look at. All right, so now that we've talked about all of the things that make this really hard, you can't really talk about Pokemon without talking about their types and how the different types match up against each other. So this is kind of a slightly different way than how Tammy categorized perf metrics, but I think of them as these kind of 3 high-level type matchups. So the first type matchup is, how are the metrics measured? Are they timeline-based or are they independent? Where are they measured? Are they field, real user monitoring, or are they only available in lab or synthetic? And then finally, what are they measuring? Are they primary measurements that actually track something that's important about the user experience? Or are they diagnostic metrics, which is kind of like the everything else bucket that you're going to use when you need to diagnose what went wrong? So first, all right, timeline-based versus independent. Timeline metrics are kind of those traditional, like you start a timer at 0, a user navigates to a web page, you fire off this timestamp when all of these events happen. Timeline metrics tend to happen in generally the same order every single time, or at least in my experience. TTFB, FCP, et cetera, et cetera, et cetera. Although, of course, there's a lot of it depends caveats in there. Something to note about these kinds of metrics is kind of like what Harry was talking about this morning, that when you slow down one of the metrics really early in the pipeline, like TTFB, it's going to have this knock-on effect where all of the successive metrics in the pipeline are likely going to get a lot slower too. In my experience, timeline metrics way easier to diagnose because all you have to do is look at everything that happens in the timeline before your metric fired, right? Yay, that's easy. Independent metrics, on the other hand, are calculated independently of the loading timeline. So like FID, TBT, INP, they have this duration in milliseconds that's kind of influenced by those timeline metrics, but it isn't measured from that same 0 start time. CLS is another independent metric. It measures a cumulative value of all of these different layout shifts that could happen at any point during the page load lifecycle. So my experience is that these kinds of independent metrics are generally a lot harder to diagnose because there's a much higher chance of variability between what you're capturing in RUM and what you can see in synthetic. And we're going to talk about that a little more in depth right now. So where are these metrics measured? So field or RUM versus lab. And this is something I think can be kind of surprising and confusing for folks. We've talked a lot about these 2 different places, but I like to think about it with this Venn diagram of there are some that are available in just RUM, there are some that are available in just synthetic, but there's this big overlap of all of these metrics that are available to you in both. And I honestly, if you take anything away from this talk, it's that in order to be a perf detective, you have to have both of these environments. So we've talked a lot about RUM, so I'm going to kind of zip through these slides. But one thing I wanted to say about real user monitoring, there's a billion different ways you can do it. And at Etsy, we roll our own. We DIY. It's not just the website of things we sell that are DIY. We DIY too. All of our RUM is DIY. We pipe it into our A/B system. We have feature flag tooling where we can turn things on and off and run canary experiments. And I really if you are running A/B tests, you should think about adding this to your pipeline because it's so super valuable for your detective skills. Some of the pluses about RUM is it allows you to capture those real user experiences, so you can understand the full story. Of it. All of the metrics right now are focused on initial page load, but I'm really excited. I had a really long talk with Ian from the Chrome team about SPA routing and soft navigation timing that's going to be coming to Chrome. That's exciting. And there's a caveat, obviously, that these interaction-based metrics are not available to you or they're only available to you in RUM of FID and IMP. Some of the kind of meh stuff about looking at real user monitoring is that browser support is lacking for some metrics. Chrome obviously is like leading the pack here, and some of the other browsers are a little behind. And one thing I think that's interesting about RUM is like you kind of have to think of every data point that you collect as a trade-off. You can't collect all the things because we want to be good stewards of the web. We don't want to slow down our users' experiences. We don't want to go way over their data cap by like collecting a ton of metrics about every little thing. So you really have to stop and think about like what are the most important data points for me to track in my RUM so that you're not constantly like hurting your users. And again, like RUM is great to look at trends and in-depth analysis, but it's never going to be an apples to apples comparison. So it's really hard to do like in the moment analysis. And another thing people have talked about a lot about RUM populations is how do you visualize this wide range of data where you have data points coming in from users on fast devices, fast networks, and you have data points coming in from users on slow devices and networks. And everyone's been talking a lot about histograms, but at Etsy, we actually use a different kind of visualization called a cumulative distribution function, or a CDF. Now, one of the benefits of a CDF is, as you can see, it's kind of like the opposite of the histogram, where the y-axis is showing you the time in milliseconds. And then as you go out on the x-axis, that's showing you the population of users who experienced a timing either equal to or faster than a given timing. So, and I really like these visualizations for A/B experimentation purposes because you can compare different sized populations with each other. Like if you're using a histogram, and the populations are different, the buckets are going to necessarily be different sizes. So we use CDFs because that's really the best way for an experiment view. Uh-oh. Yes, like I said, I'm like super rusty at this. And you can also see, I don't know, hopefully the screenshot is big enough, but something that's really interesting when you look at RUM and you look at degradations in perf is a lot of times things that'll be a very small change at like the P5, P10, P20 level. Once you go out farther, the distance between the lines gets bigger. So very small changes that we might not notice as developers are going to be extremely noticeable to your users who are on those low-end devices that Alex is going to talk about in depth later. So let's move on to synthetic. So synthetic, again, you're collecting data in controlled conditions. There's a lot of different ways that you can do it. Some of the really cool things about synthetic monitoring when you're a detective is it lets you control the environment so you can do an apples to apples comparison. We're not concerned about potentially slowing down our users. We're not concerned about the size of the data payload. So you can capture everything. All the data is available to you in synthetic. And something I think we don't really talk about enough is that especially things like Lighthouse that are in browser, you can use that pre-production. I think it can be really frustrating sometimes for engineers to ship out a change and then cause a perf degradation and not realize it. So synthetic is super important if you're going to try to catch things before they make it out to the site. However, obviously, there's some downsides to the data that you can get. Not everything is available, including those interaction-based metrics, but we do have correlated metrics that we can look at instead, like TBT or TTI instead of FID or IMP. CLS is another really difficult one as well because it's like this continuous measurement as the user scrolls, and in most synthetic tests, like scrolling it's not impossible, it's just hard, right? All right, so our final type matchup is what do they measure? Are they primary measurements or are they diagnostic measurements? So I don't know how many of you actually have played the Pokemon video game, but there's this concept called the starters. So when you start the game, you pick one of a preset group of 3 different types of Pokemon who are like the easiest Pokemon to start with. And that's kind of how I think about Core Web Vitals. Like Core Web Vitals is your starter pack. But as you mature and as you progress, like you need to build out your party to have a wider array of different types that are going to help you handle different kinds of battles. So kind of similar to what Tammy and Nick said yesterday, I challenge all of you to go back and do some user data research and figure out like what are the metrics that matter the most for you and your users. Like, I probably shouldn't admit this on stage, but at Etsy, DCL and page load are still some of our like core primary metrics that we look at, because we've determined that those are super important for our architecture, right? Your playing style, your architecture might be different, so you might need a different subset. But it's really all about starting out with the starters and then growing your team. And then finally moving on to diagnostic metrics. These kind of just like do what they say. You use them to diagnose a problem. So looking at each of these, the first one is navigation timing. This is like the old school workhorse of perf, right? This has been around forever. It's not the hotness, because these are metrics that are largely internal to the browser. They're not going to tell you very much about what your user is really experiencing. But again, from a detective perspective, these are going to be super helpful and useful when you're trying to figure out what changed. The next metric is resource timing. And oh good, this is sort of readable. This is like a feature request for like web page test and like Lighthouse. Can we get like a screenshot mode or something that makes like the font bigger and the bars wider? Because screenshotting this is really hard. But resource timing is the underlying data that lets web page tests create this waterfall of values. It talks about what resources load, how long does it take, and the size of the resource. If you aren't already, your RUM should also be tracking the size of your HTML payload, the count of all of your assets. You can also track the bytes that come over the network versus what comes out of cache, which can be really important to understand repeat versus brand new users. Resource timing is your friend here. Something else I think we don't talk about nearly enough is tracking LCP and CLS attribution. So in synthetic, this is pretty easy, right? Like my pro tip is, if you're in web page test, open that film strip options, and then if you check the boxes, it'll show you these like red boxes that show you all of the elements that had CLS, and then a green box that shows you the LCP element. But we can also track attribution in RUM. Like, this is a lot of code, so I'll share the slides out later. But you can use your performance APIs to keep track of these specific elements. Now, the problem is if you have a lot of different pages or experiences, the data that you get has really high cardinality. So we haven't quite figured out yet how to display this to users in a coherent way, but it's good to just have it in your big query so you can do a quick query if somebody is confused about what happened. Another diagnostic metric that is important is long tasks. So again, you can look at long tasks in synthetic. This is a screenshot of Lighthouse with the avoid long main thread tasks window open. But you can also track long tasks in RUM, which we do at Etsy, and we actually aggregate the sum of the length of every single long task that fires during a session, and we use that as a proxy for TBT, because TBT is one of those things that's not available in RUM typically. You have to do it in synthetic, but we kind of use that as like a proxy. Custom timings are cool because they have 100% full cross-browser support. So you can kind of use them to create fallbacks for metrics that are not available cross-browser. So for example, at Etsy, for a long time before WebKit supported FCP, we had a custom metric we called logo paint, which was we tracked the time that the logo displayed to users, because that, from watching a whole bunch of film strips, we realized that was equivalent to FCP. So thankfully now it's available everywhere, but you can kind of come up with these workarounds when you use custom timings. And finally, there are all of those metrics that are only available in synthetic, and those fall under two kind of broad categories. The first is we have a lot more detail about JavaScript execution that we can pull. And the second one is that we have a whole bunch of extra information about rendering that's only available to us by taking one of those film strips of screenshots of images and then doing a visual comparison to see what changed. So start render, speed index, visually complete, those are only available because we have that film strip. All right, so now that we understand all of our types, let's catch some perf metrics. So completely coincidentally, 2 weeks ago, a friend of mine shared this link on Twitter. So what this is some third-party service. They published this free like AI art thing. It's kind of like Dolly, where you put in some words, and it'll automatically generate a Pokemon for you. So I've been putting words for various perf-related things into this system. Like, so here we have Tim. I put in Tim is tall, because Tim is a very tall person. And I put in Henri wears a hat while running, because if you follow Henri on Twitter, you know he always wears his hat, and he likes to run. So I'm probably not going to get asked back because I did this. But so let's take a look at what some of our perf metric Pokemon look like. LCP. This is like Chonky. He's like a chonky boy. Like, yeah, LCP. So let's open our first case file and dig into what happened when somebody killed LCP. So this, again, is a screenshot of Sonic, our internal rum tool. It's showing us the difference between the control and the variant, the on and the off, of an experiment that I found that had a 4.5% degradation in our P75 LCP. So the first thing we're going to do is we're going to take a look at actually what was the experiment, like what feature did they change. And lucky for us, the change for this experiment, it makes a lot of sense that LCP changed, because the difference is we took these images in the grid that are most likely our LCP elements, and we changed the design of them. We made them square instead of landscape. So our first step is, did the LCP element change? Now, to answer that question, we're going to pull out a trainer card. So trainer cards are like extra like bonus things. So this is our web page test trainer card. To get a good image here, I put in web page test waterfall smile, because everybody who works at web page test smiles all the time, right? So this is my first attempt to debug what's going on. I went to webpagetest.org. I selected visual comparison. I entered my on URL, my off URL. And can you see the problem? Yeah, the test agent sent a user agent over that we detected as being an unsupported browser. So we have this banner at the top that says we don't support your browser, and that's the LCP element in this test. So I had to go in and actually do a manual test to use a different browser user agent that was going to actually highlight the real LCP element for me. And as you can see, the green box is the same element in both cases. So I didn't introduce anything new that was taking over as the new LCP element. All right, so LCP element did not change. Our next question then is, did some characteristic of the LCP element change? If it's image or video, did the asset size get bigger? If it's a font, did the font somehow change? So let's pull open in web page test the resource information. So as you can see, the image size is actually smaller. So it's not that. We didn't make the images any bigger. It actually went down a little bit. However, there's a little clue here as to the real culprit. You can see that the image is discovered a little bit later than previously. So we're going to file that away, right? All right, so the next question that we need to ask is, did any of the metrics before LCP and the timeline change? So remember, those timeline metrics, you know, if you move something earlier in the timeline, you're going to shift the ones later. So let's look at our rum and see what the rum data says. So I just put rum in, and it kind of looks like a cask of rum. I think this is good. So suspect number 1, time to first bite cheetah. I had to put in cheetah to get something that wasn't like a clock. You know, everything is a clock in these. So looking at our CDF, you can see there really isn't any difference between the on and the off. The blue line and the orange line are like right on top of each other, other than a little variance in P99. So it's not FCP, or it's not TTFB. FCP, suspect number 2. I kind of like FCP. FCP is really, it's like a dog you would want to like have in your house. So looking at the CDF again, there's not a lot of difference in FCP either. It's a little bit up in the P95, but nothing significant. So we're going to look at DCL, which I struggled. I had to finally, I put in tree complete because it's all about the DOM tree. And he's cute. I would have him in my garden. But DCL, again, didn't really change, looking at the CDF. Very tiny increase in P95, but not really enough to be our culprit. So just for funsies, let's look at page load, which I ended up putting in like CSS, HTML, JavaScript, asset, blob, thing, purple. And this monstrosity came out. I was getting a little punchy at that point, right? Now this is interesting because we see that it's slightly higher even in P5. You can see there's just barely the orange line is not completely covering the blue line. And that difference gets bigger the farther that you go. So this is interesting. Okay, something is definitely going on here. So our next question that we want to ask is, did the loading order change? So again, I pulled up the waterfall in web page test. And as you can see, our LCP image loads in as number 12. But in the after, whoops, you can see, look, a wild CSS file has appeared. And our LCP element got pushed down. Yes, somebody plays Pokemon. I see some smiles. It's been pushed down to 13 in our list. All right, so hey, wow, we found an answer to one of our questions. And the final question that we want to ask is, did the render blocking assets grow in size or number? We already know the answer to that, but let's just confirm it by looking at the number of requests that we have. We have one additional CSS request in the on, and we have double the bytes. So, ta-da! Yay, we found our culprit. We know what caused LCP to get lower. Now, I'm not going to talk about how to fix any of this because there's just not enough time, but that's for another day. So our next case, CLS is a moving paint ghost, and he's like, this is like my sad baby, like he's blobby baby. I love CLS. So this experiment I found is really, really interesting because not only did CLS get worse, but a little bit of everything got worse. In particular, their LCP and page load got worse. But CLS got 58% worse with this, although a little bit of like a humble brag is that getting 58% worse means it went from 0.012 to 0.019. So like, yeah, our CLS is great. So let's look at what changed. So if you look at the before on the left and the after on the right, we have this new module that's loading in above the fold on our search results page. So this is probably why LCP is 23% slower too, because I'm guessing that one of these new things became our new LCP element. And we're loading a whole bunch of new images, so no wonder page load got worse, right? But let's take a look at CLS. So CLS actually, I think, is really, really, really easy to diagnose because there's only 4 possible causes. First, either you have FOUT or FOIT, so flash of unstyled text or flash of invisible text in your font that's loading. You either have images without dimensions, either you're lazy loading content without a correct height placeholder, or you're injecting some kind of like a banner or an ad or an iframe that doesn't have an initial height and takes up space once it loads. So to turn to Lighthouse, our next trainer card, this one I just put in Lighthouse in like this kind of slothy or snaily, blobby thing. I don't know. I like it. No notes. So I ran Lighthouse in the browser to compare the before and the after, and the score didn't change. But there is a change in CLS going from 0.002 to 0.0025 or 0.025. So we're going to take a look at all those audits that are relevant to CLS. And then if you open the tab that says Avoid Large Layout Shifts, you're going to see this awesome view that shows you screenshots of every single element that shifted, and then the classes and IDs that are applied to the elements that actually moved. Now remember what I showed earlier, like this is something that you can track in your RUM too, but it's just way easier to have it like visually available to you. Now the one on the right has that new section in there on the top, but like the image is really hard to see, so we're going to enhance. And so practically the whole page is highlighted as a layout shift. And you can see the highlight actually begins below that new section that got added in as part of this experiment. So we're narrowing it down. So basically, the new module is doing something that's causing all of the content underneath it to shift. So to understand what happened, I have a video here. I made a really, really, really slow network. So, okay, this is interesting. So like the regular search results load in first. And then you can see there's a little pop where the font on the top loads in, and the links go from 1 line to 2 lines. And then this section is still, oh, okay, did you see it? So so when the skeleton screen went away and the actual content loaded in, the height of the images plus text was actually shorter than the height of the placeholder. So we have our culprit. This is bad because what happens is the entire block of content underneath it shifts upwards, and that's going to be a much higher CLS score than like a very small change. All right, so ta-da, yay, we figured it out. And I just have to show this guy again because I mean, it's horrific, but wonderful. Next up, we're going to look at FID. This is Touch Sloth. He's very cute. I like him. I think I would make a stuffy, like a plush animal out of him. So another kind of hashtag humble brag, I really struggled to find an experiment where FID degraded because we have really good FID. But I found one that had a 15% degradation at P75, but it's going from 26 milliseconds to 30 milliseconds. So yeah, this was the best I could do. So what is this change? So this change is also on search, and it adds this little add to cart button to certain search result cards. Now, when I first look at this, I was like, oh, sweet, like this is going to be so easy. This is a button. It probably opens an overlay. I'm sure there's a whole ton of additional JavaScript that's executing. Like this, clearly FID is going to get longer from this. However, I went and looked, and we have phenomenal developers at Etsy who understand progressive enhancement. And all this is it's just a form tag with a button that does a post directly to our cart page. So no JavaScript is involved whatsoever in this button. So that's, I mean, it's good for our users, but bad for us because this is going to make it really hard to figure out what's going on. All right, so there's no additional JavaScript there, but let's do our due diligence and see if there are any more long tasks, because our long JavaScript weirdos go hand in hand with FID. He looks like he's like broke out of prison. So for these graphs, I ended up turning on our log scale view just to make it a little clearer, the difference, because the difference is not very big. But here you can see that, yes, indeed, long task time is a little bit longer in the lower populations. And then it kind of evens out in the middle, and then it gets wider again at the end. And these kinds of changes, like this in one graph illustrates why you don't look at an average. Because if you averaged out the difference in values in this graph, it would be 0. Because the difference at the end, it goes up in the end and at the beginning. So there, the difference isn't good. So this is why we look at P75. So okay, were there additional long tasks? Yes, yeah, we found evidence of that. So our next question to answer is there more JavaScript downloading? And we're going to check both our first party and our third party. And we're going to look at resource timing for that. And I really like this resource timing animal, I think I put it in. He kind of looks like he's like the brain at the center of like the Starship Enterprise or something, but like a cat. So these graphs, these are inconclusive, I would say. So you can see there's a couple spots, so the graph on the left there, that's the total count of the number of JavaScript files that are downloaded. That middle graph is showing the total byte length of all of the decoded JavaScript. And then the one all the way over on the right is showing the total bytes downloaded. And so the reason why there's a whole bunch of zeros on that graph is because a lot of people are visiting and they're pulling all of their JavaScript out of the browser's cache. So they don't actually download any new JavaScript during their visit. And I mean, all of these graphs are kind of a little inconclusive. Like I look at these and I think, okay, this is noise. I don't think this is actually like a real change that's going to cause that bump in our P75. So yeah, so the answer, no, maybe, I think it's no. So the next thing we're going to look at is our TBT. So this is total blocking time whale. And he's also I would make a stuffed animal of him. He's very cute. And then our other friend TTI, which this is TTI JavaScript janky animal. And spoiler alert, I ran about 30 different synthetic tests on the before and after, and every single one of them was inconclusive. All right, Detective Pikachu is really sad. Like, I tried my darndest to figure out what was going on here. I mean, yesterday I was editing my slides and like running tests in the middle of other people speaking because I just wanted to figure this out, but I couldn't. And I think that's actually something that's a really important lesson. Like yeah, everybody's been kind of like shitting on FID, and I would also join that crew of like, this is why FID sucks. There's no attribution. It's so hard to figure out what happened. But, you know, sometimes you're not going to find the answer, right? And there's one more question that we can ask for FID, which I think is what makes it doubly difficult, is that FID could also get worse because your user's behavior changed. And what do I mean by that? I mean, the user could be clicking on something way earlier in the page lifecycle than they previously were, whereas before, maybe they would have waited until after all of your JavaScript was done, parsing and executing and downloading. And now, for whatever reason, they're tapping earlier, and they do it in the middle of when the main thread is blocked. So did user behavior change? I mean, maybe with this. Maybe that's possible that people were tapping that add to cart button. But I don't know. Like, that's really hard to figure out. Sometimes that's obvious. Sometimes it's not. So yeah, 5, can we please, Yoav, wherever you are, I know you're here, can we get FID attribution like tomorrow, maybe? Yeah, today. Thank you. And I don't know, maybe INP dude is gonna save us from FID. I really hope so, but as with everyone yesterday, I just have a big question mark when it comes to INP because I don't know, we haven't started tracking it yet, but my fingers are crossed that it's gonna be a lot better than FID. All right, so what did we learn? Well, I think the first thing that we learned is that really this all starts with monitoring. Like, you can't be a perf detective if you're not already doing some kind of continuous monitoring of your performance over time. And I think the other thing that we learned is that, you know, if all you're doing is kind of tracking high-level metrics over time without also having individual granular tracking at like a feature level, an A/B experiment level, if you're looking back in the past and you all of a sudden see a dip, it's going to be really, really, really hard to detect because it's going to be really hard to find a before and an after state. So, you know, for all of the like companies out there that are listening, I think that having perf data mixed in with your A/B test data is like the next big thing that's coming for perf. If you want to give me a whole lot of VC money to like quit my job and go make this product, I will do that. Another thing that we learned is that like perf detecting, it's not magic. It feels like magic. It feels like someone walks in the room and is just like, oh, I know exactly what this is. But no, there's actually a structure underneath it. There are very specific connections between these metrics. I know there's a lot of them. There are all the 3-letter acronyms. But, you know, it's not magic. You can learn how to do this. And the final thing that we learned is, of course, it depends. Like, it depends. You know, this is actually funny, you know, that Nolan and I both said this. So at another conference, I made a joke website called askastaffengineer.com. So if you want to go pull up your phone and go to askastaffengineer.com, like, I will always be there for you to tell you that it depends. And yeah, that's it. I totally forgot to do a slide that says thank you. So
Well, don't worry about the slide, because I'm going to say thank you.
Thank you.
No, thank you.
No, thank you.
Thank you. We'll do that for 15 minutes. First of all, how are you doing?
Good.
I believe, it's funny, Katie and I have had just multiple millions of interactions on Twitter, but I think we're meeting for the first time here.
I don't know.
I feel like it is. I'm just like blanking out, but I don't get to see you enough, so
No.
I'm happy to see you.
I don't get to see any of these people enough, I would say.
Absolutely. And like you said, well, like we've been saying, it's community. Thank you for that talk. You know, and this is something, again, like the detective nature of the work is super interesting. Mm-hmm. And it's, you know, it could feel like at times like it's just a massively long task.
Yes.
You know, and we're just like poking around.
Yeah, absolutely. And I think that, it's funny, I kind of made this talk because I feel like a lot of times in my job, that's what I end up doing is that teams will run an experiment, they'll see a regression, they'll show up in the perf channel, and they'll be like, oh, this metric changed, I don't know what happened. And so I have to kind of walk them through this detective process. So it seems like a good idea for a talk.
Yeah, it is, absolutely. Thank you for the new avatar. I think I'm going to use it.
Yeah, you're welcome.
Someone told me on Twitter, like, yeah, you should change yours. And I think Tim left to change his right now.
Yeah.
I'm going to get to a question that came on here. Let me start with this one right here, which was, how do you avoid avoidance on the RUM CDF?
How do you avoid what?
How do you avoid, variance on the RUM CDF?
Yeah, well, you just have to collect a whole lot of data points, basically. I think a lot of times what'll happen, I think I showed a couple of the CDF graphs where there was only a difference in P99, and I think that was just variability in the data. Like P99 tends to shift around quite a bit, but I think a lot of it too is just making sure that when you're doing your experiment bucketing of your populations, that you're really, really careful and dialed in to make sure you're not accidentally capturing data or letting the experiment kind of like bleed out into the rest of your code base, because you want to know that, okay, I'm capturing this exact experiment. I know I can kind of trust it. And then, it's all about just making sure that you calculate your p-value. We actually do a whole thing where we calculate the p-value, and we don't show graphs until we have enough data points where we're over the 0.05 p-value threshold, where we're confident that we detected a change.
Yeah. I'm going to sort of like step back for a hot second and talk about, before we get to another question, Sergey.
Yes.
Who's on your team.
Yes.
By the way, Sergey, who runs the New York Web Performance Meetup, long time going. Great meetup that's actually in person and online as well. I mentioned him simply because, Etsy has, and I'm stepping back because we had a conversation on culture. Etsy has a great performance culture. Did you want to comment quickly on that?
Yeah. Well, I think really, it all started with Lara Hogan, you know, and Dora mentioned Lara Hogan, talked about her, but I think that, the important thing is that you have performance monitoring that matches up with your development culture. And at Etsy, that's 100% experiments. We don't do anything without putting it behind a feature flag. And so we spent a lot of time and money investing in performance monitoring that meets our engineers where they're at. Like if we just had a graph somewhere with perf budgets that alerted when somebody went over a perf budget, that's not going to be nearly as impactful as engineers who are running an experiment and checking in on it every day, getting an alert directly on their experiment result page saying, hey, we've detected a change in your performance, either for good or for bad. So I think that's a big key thing. And also Kellen, who Dora also mentioned, he was one of the kind of founding engineers at Etsy, and a big reason why we have the culture that we have, and use boring tech is our thing. So
awesome.
Yeah.
Nice. Thank you very much for that insight.
Yeah.
Let me see. We have another question coming in here. When you run so many perf experiments a year, do you focus primarily on better perf metrics, or do you always / often look at business impact as well?
Yes. We look at both. And I will say that the vast majority of the experiments that we're running are not necessarily perf focused. They're just feature experiments where we're trying to, build a new feature that's going to get users to have more engagement, and we just make sure that we kind of build performance into that. When we are looking at perf metrics, we do a correlation with things like conversion and business KPIs. But I found that that's actually really, really hard to get right and to do well. We stole Paul Calvano from Akamai, mainly because we wanted him to come in and help us figure that out, because perf is so variable, and when you think about it, it really only impacts that very first view of a page or an experience, and that if a user keeps coming back, the perf experience is going to completely change as they're pulling more stuff out of cache. And so we found that like trying to track that over time gets really hard because the impact of the change gets diluted the longer that people stay in your experiment bucket and the more their kind of reload, second load experience like gets better. Perf is like that first impression thing that if it's bad, it's bad. If it's good, nobody notices it.
Amazing. Now, I gotta say this. Paul Calvino almost joined Web Page Test. So
yes, we won. We won.
I'm just gonna leave it at that. We're still friends. We're still friends.
We're all still friends.
Yeah.
We're totally friends.
I'm gonna go with this last question here. Let me see. What do I have? How many dashboards do you keep track of? I'm assuming, considering you might be running multiple experiments at once.
Yeah. So we have kind of overall dashboards where we're tracking P50, P75, and P95 on a per page basis for all of our core metrics that we care about. Mm-hmm. And then each individual experiment gets its own set of graphs. So we have both. We have like kind of dashboards that we look at over time. We have alerting set up for them. But then additionally on top of that, for every single experiment that runs, we generate a dashboard that's specific to that.
Awesome. Well, thank you very much for that.
Thank you.
It was a delightful talk.
Yes, it's
and
lovely
good
to be
see
here.
You. And as a East Coaster, we good.
Yeah.
All right. Give it up for Katie, please.